Hello, let's discuss implement router question from today's Leetcode contest. Design a data structure that can efficiently manage data packets in network router. Each data packet consists of following attributes: a source, unique identifier for the machine that generated, destination, the target machine, the timestamp, the time at which packet arrived. Implement the router class with the following functionalities. The first one is add packet, source, destination, and timestamp. This should add a packet and it should return false if there exists exactly same packet in the past. If there is no same packet, then return true. And the second one is forward packet. So this should remove the packet according to FIFO principle, and we have to return the packet which is removed. If there are no packets, return an empty array. And the last one is get count. Given the destination and start time and end time, we have to return the number of packets currently stored in the router, that is which are not forwarded, that have the specified destination, and the timestamps are between start time and end time. So the constraints are the memory limit. The memory limit is the maximum number of packets the router can store. It can go up to 1E5. The source and destination are up to 2E5. The timestamp and start time and time are up to 1E9. At most 10 power 5 calls will be made to add packet, forward packet, and get count. Queries will be made in the increasing order of timestamp. Let's discuss what are the required functionalities and data structures required. So the first one is add packet. So a packet is considered duplicate if other packet with the same source, destination, and timestamp already exist in the router. So we want to find whether there exists a similar packet in the past with source S, destination D, and timestamp T in the past network. So if it exists, we have to return 0, else we have to return 1. So we can simply use a set of vector with 3 elements visited, so that if we can store the present packet vector into the set, and in the future if the same packet will arrive, we can return 0. So this is the first functionality, add packet. The second one is forward packet. So it should forward the next packet in FIFO order. So what is FIFO? It should remove the first packet which is inserted first. If we are adding here, we have to remove the first one because this is the first one that is added to the network. So for FIFO, the data structure we use is queue. So we can use queue here with a vector which shows source, timestamp, and destination, or source, destination, timestamp. And the next one is get count. We have to return the number of packets with timestamp in between start time and end time with destination D, and which are not forwarded yet. So we want the number of packets. So we want a type of map with a destination D and all the packets which have this destination, so that we can try to traverse this or do some kind of other trick to get the answer. So for this kind of function, we want a destination and the packets which have destination of this as the destination. So we can use unordered map of int and some other a map. But why Deque of int? Let's discuss in the aftercode. So the basic data structures we require are set to find whether there exists a exactly past one, and the queue to implement forward packet because we have to forward the next packet in FIFO order, and next the get count. We want for a destination what are the number of packets which are not forwarded yet and have timestamps between these. So we want some kind of map with D and some kind of packets. So let's just discussing the add packet one. So what should the add packet do? So firstly we can find we can make the vector with source, destination, and timestamp, and we can find whether it is already present in the set or not. So if visited.find not equal to visited in, so it means that there is an exactly similar packet in the past. So we have to return 0 as per the question. And now they also given that if adding a new packet would exceed this limit, the oldest packet must be removed to free up the space. So if the size of queue is n, so what is queue? The queue stores all the packets which are arrived. So before adding the packet, if the size is n, which is the maximum limit they gave, so if this exceeds, we cannot add a new one. So to add a new one, we have to remove the oldest one. The oldest one means which have the least timestamp. So if the size of the queue is n, which means it is a full, so we can pop the first one, and we also can erase from the set because this is no longer in our network. This is being removed, and now we are finding the destination and the timestamp of the packet we have removed. And similarly, we are storing some kind of vector with a destination. As this packet is being removed, it also has the least timestamp because we are removing the least timestamp one. So even for this destination, the packet we remove is the first one because it has least timestamp. So we are finding the map of that, a kind of vector for that destination D. And if it is not empty, we are removing the first one because we are removing the first packet. So if that it is empty, we are removing just the destination because there is no meaning to store a destination D with no packets which have to be forwarded. So we can just simply remove from the map. And finally, we have achieved all the functionalities. We have removed from the packet, we have removed from the map, we have removed from the set as well. So finally, it's the time to insert this into the queue. So we are pushing this into queue because this is the new one. And similarly, we are adding inserting in the queue because this is the past packet for the future packets. And similarly, we are adding the map destination, the present timestamp. So we are finally adding the timestamp of this to this vector in the last because this is the latest one of all with this destination. So and finally we are returning one because we have successfully added a packet to the network. And the next one is forward packet. So what should the forward packet do? It should forward the next packet in FIFO order. So similarly we are taking the front one of the queue, which is the first FIFO one. It has arrived in the first, so we are trying to remove it now. So we are taking the front one and popping it. Similarly, we are removing from the set because this is being forwarded so that it is not in the network in this network anymore. This is going to the next network, which is not in our consideration. So we are removing this and we are finding the source, destination and the timestamp of this packet. And similarly, we are finding the map of the present destination. Similarly, if it is not empty, we are popping it because this is no longer in our network. We are forwarding it to the next one. So we are removing the first one. And similarly, if it is empty, we are erasing it and finally returning the packet which we are forwarding now. And now coming to the next one, get count. So now let's discuss why we have used another kind of vector Deque. So Deque is a kind of data structure where we can add in the forward, add in the front, add in the back, remove from the back as well, and remove from the front as well. In this functionality, we want to remove the least timestamp one because we have to forward this or remove this. So if we try to use a vector, we can add in the backward and we can pop in the backward. We can not add in the front or remove from the front. But our main functionality for this get count is for a given destination, if the size of the queue is full or if the packet is being forwarded, it is no longer in the network and we have to remove the first one. And similarly, if a packet is there and its destination is D, we have to add it in the last. So we want a pop front and push back as well. So we have to use a Deque here so that we can achieve both functionalities in of one. And now let's discuss this functionality. So for the destination this, we have to find the number of packets with timestamp between start time and end time. So first we are finding whether there are any packets. So if the map is end, it means there are no packets with this destination. So there are no packets, so return 0. And now we are taking the Deque for the destination D, and we want greater than or equal to start time and less than or equal to end time because we want between this one, so these should be greater than or equal to S and less than or equal to E. So we can use a lower bound in the Deque with the start time. This will return the iterator to the first one which is greater than or equal to start time. So lower bound returns the pointer or iterator to the element if it exists with a value greater than or equal to start. So we are using lower bound to get the highest one, which the lowest one, which is greater than or equal to start time. Similarly, we want the one which is greater than the e, so that we can take all elements up to this, up to before one. So auto it2 is equal to upper bound of similarly the deque and end time. So the upper bound returns the iterator with a value greater than end time. So we got the iterator to the value which is greater than or equal to s, and we got another iterator with a value greater than e. But this is not in our answer, so we want up to the last iterator of I22, that is it2 minus minus. So the distance works like this. So distance of first iterator and second iterator returns the distance between the first one and the last but one. So here we are using distance of it1 and it2. This is it1 and this is it2. So according to the syntax of distance, it will consider the pointers up to 2 but not 2. So it will consider only iterators less than or equal to this one. So we can get the number of packets with the timestamp with the start and ended. So we have to use queue for forward packets, set for add packet, and destination to times for get count. If you have any doubts, comment below, drop a like. See you in the next one.